Hi everyone, my name is Amir Imani. I'm an AI ML solutions architect at AWS. I'm excited to be here today. Today we're going to talk about relevant SageMaker use cases for media and entertainment. The media and entertainment market encompasses every broadcasting medium from newspapers, magazines, TV, and radio, and popular forms of entertainment such as film, music, and books. According to Statista, the global M&E industry will grow to 2.5 billion in 2024. This growth is being largely driven by video, and projections indicate that internet video will see the most compound annual growth rate as consumers are watching more content than ever before. While the industry is growing, we have seen the following trends and challenges. Consumers are increasingly expecting new forms of media to engage with and new ways to consume content. That's why media entertainment companies are looking to innovate rapidly to meet this demand. For example, the virtual reality market is quickly transforming into an entertainment and productivity platform. At the same time, content distributors and aggregators are looking at ways to tailor content recommendations at scale. Many M&E companies are looking to customize customer experience since personalized content has higher chance of being engaged with, as opposed to just simply providing a list of popular content. But the challenge is that as many media entertainment companies are looking to find ways machine learning can help transform the customer experience, data scientists who are building machine learning models need large volumes of data over time to create more impactful customer experience that will lead to higher customer adoption. Also, in terms of internal processes, with increasing content volumes, media entertainment companies are facing challenges in preparing and managing content. Those internal processes are crucial to providing a high quality viewing experience and increasing content monetization. Today, companies use large teams of trained human workforces to perform tasks such as finding where the end credits begins in a piece of content, choosing the right spots to insert ads or window of opportunity for putting ads in their content, or breaking up videos into smaller clips for better indexing. These manual processes are expensive, slow, and cannot scale to keep up with the volume of content being produced. That's why many M&E companies are turning to machine learning. And the last trend we see is the effort to improve content personalization. Personalization at the highest level is how an organization delivers more customized interactions and unique experience for the users. Personalization is a means of meeting consumer expectations by delivering the right experience. That means what show do I watch at the right time? Is it the weekend or before I go to bed? And the right place on the app that I'm currently watching or a TV set. In fact, according to Redpoint Global, 63% of consumers see this type of experience as the standard level of service. For many media entertainment companies, recommendation engines are becoming essential to acquiring new customers and retaining them. Many consumers today expect real-time curated experience across digital channels as they consider, purchase, and use products and services. Many M&E companies are turning to machine learning to provide that personalized recommendation. But building a personalized service is difficult because there are many variables to account for everyone's different preference. Also, creating a seamless personalized experience across multiple consumer channels and touchpoints, such as social media, ads, emails, and websites, is hard. Because of the disparate platforms, many M&E organizations may struggle with easily integrating a personalization solution into their existing platform and workflows. These are a few examples of how companies are turning to machine learning to solve those business challenges that we discussed. Companies are using machine learning to deliver highly personalized experience, which results in improvement in customer engagement, conversion, revenue, and differentiation in a digital world. Machine learning makes this task easier by analyzing data from multiple channels and delivering unique experience to individuals based on their behavior. Those behaviors can be customer order history, shopping patterns, um, and they're used to adopt their taste and preference and help media and entertainment companies to deliver customized experience. Another use case is reducing customer churn. Customer churn is really important because retaining your customer is one of the primary growth pillars for products with a subscription-based business model. To improve customer retention, media and entertainment companies look for trends and patterns to understand which offers, services, and content to provide to customers. By using machine learning, media and entertainment companies can analyze massive amounts of detailed product usage logs and purchase history, uncover user behavior patterns to identify at-risk users of churning, and retain and grow their user base. Another use case of machine learning is helping to extract and analyze data from documents. With machine learning, media and entertainment companies can process documents such as sign-up forms and contracts. They can process them faster and more accurately, which reduces errors caused from manual entry. Natural language processing, or NLP, helps media businesses to convert textual data in print, handwritten and electronic documents into digital information that can be readily discovered and analyzed to make decisions more quickly. Sports companies in particular are all looking to improve the fan experience, create customer loyalty, and help fans better understand the game. Machine learning creates new and unique ways to engage their fans at scale, such as predicting live sports outcomes and providing statistics for viewers. So, how Amazon SageMaker comes into this picture? If you're not already familiar with SageMaker, we built Amazon SageMaker from the ground up to provide every developer and data scientist with the ability to build, train, and deploy machine learning models quickly and at lower cost by providing the tools that they require for every step of the machine learning development lifecycle. It's all in one integrated, fully managed service. SageMaker has a lot of different features and capabilities. We typically talk about those capabilities as falling into four categories. As you see on the slides, on the left, we have data preparation, then the model build phase, training and tuning, and deployment and management. These four categories really address the needs that machine learning builders have when dealing with each stage of a model's lifecycle. Using SageMaker has many benefits. To name a few, it will accelerate the machine learning development with more than 20 plus purpose-built tools that we have. These tools range from Amazon SageMaker Data Wrangler for data preparation to SageMaker pipelines for workflow and SageMaker Clarify for bias detection. SageMaker can boost your productivity. It is the first IDE designed specifically for machine learning that brings everything you need for machine learning lifecycle under one unified visual interface. It also eliminates costs of writing custom integration code by leveraging tightly integrated Amazon SageMaker capabilities for data prep, debugging, bias analysis, training, deployment, and model monitoring. Now, going back to the use cases, as we discussed, consumers today expect real-time curated experiences across digital channels as they consider to purchase or use products and services. With Amazon SageMaker, media and entertainment companies can build machine learning models to deliver that customized and unique experience. That experience can improve customer satisfaction and grow their business rapidly. SageMaker provides built-in machine learning algorithms such as factorization machine and XGBoost that are optimized for personalization. You also have the option to use AutoML with SageMaker Autopilot to automatically generate personalization models and deploy the model to production with one click. You can also explore SageMaker Jumpstart, which provides personalized recommendation solutions, including sample datasets, reference architecture, and even AWS CloudFormation templates. Also, with Amazon SageMaker, you can build machine learning models to predict abandoners in order to take remedial actions. Those actions can be sending promotional offers or sending personalized emails to speed up onboarding and encourage product use. And over time, as they use more data to train models, prediction get more accurate, so they can identify early indicators that certain customers may churn. SageMaker provides capabilities to create automated workflows and pipelines, so you can continuously deploy updates to churn prediction models in production. You can also use SageMaker Jumpstart for churn prediction solutions. They can be deployed readily with just a few clicks. And as mentioned before, they include sample datasets, reference architecture, and AWS CloudFormation. Lastly, with Amazon SageMaker, media and entertainment companies can build machine learning models to automatically process and analyze data from handwritten and electronic documents, so they can process documents faster and more accurately and cost-effectively. SageMaker provides built-in algorithms such as blazing text and linear learner that are optimized for text classification, natural language processing, and optical character recognition like OCR. SageMaker Jumpstart also provides solutions that can be deployed readily with just a few clicks. Finally, SageMaker also integrates with Hugging Face, making it easy to leverage models from the world's most popular NLP model library. Now, we will walk through an example for customer churn analysis. In this example, I'll show you how to use various SageMaker capabilities to create an end-to-end prediction model. You'll see steps like data cleaning, feature engineering, model training, hyperparameter tuning, deploying the model, and model explainability. For this example, it's required that you have SageMaker Studio set up and configured. To learn how to set up SageMaker Studio, please check the onboarding video link in the notebook. There are 3 parts in this demo. They're separated in different notebooks. In Notebook 0, we'll have an overview of the problem and data prep and exploration. Notebook 1, we do pre-processing and feature engineering using SageMaker Processing. And in the last notebook, we'll build the model, train, tune, and deploy it. So SageMaker Studio resembles a Jupyter Lab environment. We are opening the first notebook here, notebook number 0. You'll have to pick your kernel. Here I'm using Python 3 data science kernel. There are other kernels that you can pick. They come with pre-installed libraries if you need them. So going to the problem, we are using a simulated user data from a music streaming service. The idea is that how can we predict if a customer is going to churn or not? In subscription businesses, it is important to know your customers and their behavior and if a customer will churn or not. There are also other ways to look at this problem. For example, if your customer will downgrade their pricing plan, or if a new customer will subscribe or renew their subscription. There are different ways to look at it. In this example, we will define the problem in a way to predict if a customer will cancel their plan or subscription. The problem with these churn analysis is that data comes from different sources. It can be from CRM, from user data, engagement and usage behavior, and passive feedback that it provides. So they come in different forms, in different sources. You need to normalize and process the data. Sometimes you don't even have the right data, so you need to use your business knowledge and judgment to create proxy or transform the data in a way that can lead to an analysis that you want to run. So you can check the data, the kind of issues that we have in a bigger churn analysis. In this particular example, we have a series of metadata about the user, some usage data on the platform in each session that I have. We'll go through the data step by step to see which columns are relevant, which are not, and how we can use them. Overall, this is the architecture diagram of this example. You see that we're using range of SageMaker capabilities from data Wrangler in Notebook 0 to SageMaker Processing and experiments and hyperparameter tuning in the following notebooks. And at the end, we are using SageMaker Clarify to add explainability to the predicted results. So that's something that we'll see in similar notebooks or projects, installing required libraries with the version that you want. You have the flexibility of SageMaker kernels come with pre-installed libraries, but you always have the option to install the versions of those libraries that you require, or new libraries if they're missing from your kernel. Importing the required libraries, we're setting up the sessions and clients and configuration to use SageMaker resources here. Here I'm using a Store Magic. Here is a really useful widget that you can use to carry variables from one notebook to another. Because we're using 3 notebooks in this example, that's really helpful not to copy pasting all these values across notebooks. Downloading the data here from an S3 bucket to our SageMaker Studio, unzipping the data. They're coming in different partitions. Just a usual kind of, having the data, putting it together, and then unzipping those zipped files and put that back to our own S3 bucket. So this is my default bucket location for SageMaker. You can define it yourself, and that's where the data is being stored. Going through the data, you can look into, here we're looking at the head of the data with 2 rows. What are the values that you can see here? Overall, this is a important part of machine learning, to explore your data, do exploratory data analysis in order to familiarize yourself with the features or columns that are given to you, and the distribution of your values. For this example, I'm dropping 4 columns because I don't think that they're relevant to my churn analysis. Columns like first name, last name, and some API methods that were used for each session that the user had. So these are not adding any information to my analysis. Then looking at 2 null values in my data, you can see some columns are, complete, there's no missing values. Some have about 20% missing values. The most important thing is that in this example, I want to make sure that user IDs and registration status is not missing, because if I don't have information about that, I can't do any prediction, in particular for registration. And user ID is my main identifier of each user. So I want to make sure that they are not missing. And now we're getting to looking to other columns. You can always check your categorical columns to see how many unique values they have. Here, you can see, for example, for location, we have 72 unique values. That might not be useful. That can, in this example, there are approaches that you can use, for example, to aggregate these locations, as opposed to have every state or unique value. You can group them together. Here it's in United States, so you can have New York and some other Northeast states as one group. These are different ways that you can pre-process your data. Same for other columns. For example, artists, we have every individual artist, about 16,000. That might not be useful for the churn analysis. Maybe we can transform that column to the number of artists that a particular user listened to, as opposed to have the individual artist name. So there are different ways based on your problem, business challenge, that you can aggregate or transform your data. I'm also dropping location and user agent. I don't think that location will add any value for this example. And user agent shows the device type. This is not relevant for this example. It might be relevant in another problem. Here we're having a closer look at the timestamp columns, TS and registration. There are different ways to deal with time data. You can separate it to days, weeks, hours, and that can be useful to aggregate. For example, you can use that to look into users' behavior in different days of the week, or different seasons, or different hours. So that can be a useful information. Here we are defining our target, as we discussed, to be if users are canceling their subscription. In the page column, we have a value for cancellation confirmation. There are other values here. We will aggregate all the other values to not churned, and if the cancellation confirmation is the value there, we'll take that as a churned user. You can see after doing that aggregation, we have about 13% of users churned. That's one of the issues with churn analysis. Usually the majority of users don't churn. So we're dealing with the imbalanced data set. There are different ways to handle imbalance. In this example, we're using SMOT, which is a strategy to upsample minority class. So yeah, you can do all the data exploration in SageMaker Studio, looking at the distribution of data, if there is any meaningful difference between churned users and active users, consumption in weekdays and weekends, looking at the distribution of music consumption in a day, like different hours. So you can have that kind of exploratory data analysis in SageMaker, and make sure that you are familiar with your data and your users. Now, I want to introduce a new feature that was released in reInvent 2020. I want to introduce you to SageMaker Data Wrangler. It's a capability of SageMaker that you can use to process and prepare your data and make it ready for machine learning. To use Data Wrangler, we have to have our data in CSV format. That's what I'm doing here, getting all those raw data that we uploaded to SageMaker and put them in a one unified CSV file using SageMaker Processing. This will take some time, but you'll see the result will be stored as a full data.csv. And you'll get some information about the job and how long did it take. To use SageMaker Data Wrangler, you have to use SageMaker Console. It's a graphical user interface, or GUI. You'll see where your data is, and you'll see the columns. And you can add transformations on your columns as you want. And at the end, you can export that as a Data Wrangler job and use it to process your data. In this example, there's a .flow file here that feel free to open it up and see how data's Wrangler looks like and what kind of transformation we've done here. That concludes our exploratory data analysis and visualization. But now we're moving to notebook 1. That's where we are doing the feature engineering and pre-processing using SageMaker Processing and make the data ready for model building. So while in the previous notebook, we used Data Wrangler to have a GUI to process the data, that might not be always a use case. In this notebook, you'll see how we can use SageMaker Processing to do the feature engineering and data prep steps that are necessary for our data to be ready for our model phase. So again, same information from previous notebook about the problem and problem definition. We are using SageMaker Processing for feature engineering. Throughout our exploratory data analysis, we can come up with a series of steps that we need to do on our data. Things from, as we discussed, aggregating locations or dropping columns, breaking down timestamps to different time elements. All of that are being done in this script. So you can see we are converting date to time and weekdays. We are creating the label column. So if it's 1 if a user has canceled their account, or 0 for everything else. You can see we are grouping by user ID. And a few more steps to take to transform our categorical data. And you can see that we are doing a few more transformation on our data in this script. You can add, you can use this as a guide if you need to add more steps to your own data or your own problem. It will be in the same fashion. All we need to do after putting all those transformations in the script is to store the final result in a specific path. SageMaker Processing will take this script, We'll start EC2 instance. We'll run all the transformations that you specified, and we'll store the result back to S3. To do that, you need to make sure that you are saving the final data that you have in this particular location. And by doing that, SageMaker Processing can automatically pick the final result, store it to S3, and once the job is done, it will terminate the EC2 instance. So to use that script in a SageMaker Processing job, what you need to do is to create a scikit-learn processor. We'll pass the script that was written in the above block to the processor. You need to specify where the output needs to be stored on S3 from the destination and from the source on your processing job. And at the end, you can start the job by running by the .run command here. You'll see the logs. It will take some time, but by the end of the processing job, which took 6 minutes, you'll have the final result stored to the designated S3 location. You can see all that information by looking into the job description. You can see that my output location, for example, is passed as to be in this particular place on S3. So once all this processing job is done and feature transformation are done, I'll take the result from S3 back to the SageMaker Studio, and I have to split the data to train, validation, and test set. As you can see here, that's done here, and then we'll store that back to S3. So now I'm separating my train, test, and validation data, and I'm storing that back to S3. That would be all we need to do to process the data and make it ready for modeling. That will take us to notebook 2, where we are taking that splitted data for train, test, and validation, and we'll build a model. For modeling, I'm using a built-in XGBoost algorithm from SageMaker. XGBoost is a popular and efficient open source library, but SageMaker has an implementation that is more memory efficient and is being optimized to be used on SageMaker. So that's what I'm doing here. I'm getting that algorithm from SageMaker. There are about 17 other built-in algorithms that you can check on SageMaker website for other purposes. Here, I'm passing hyperparameters for the XGBoost algorithm, and all I need to do to run an XGBoost model for the classification problem that I have is to create an estimator object with the XGBoost algorithm, execution role for SageMaker, and some instance configuration, what type of instance I'm running this training job on, and how many of those instances do I want. Also need to specify the output path for the estimator. That means once SageMaker starts training your model on the data, once the job is done, it will store all the model artifacts to this specific path on S3. I'm setting the hyperparameters, and at the end, specifying the input for that estimator. Training input will include the train data and validation data in order to train and validate the algorithm. Once all of these settings and configurations are done, you can simply fit your estimator on your input data. You can see, you'll see logs of the training job, what is the training AUC and validation AUC throughout your training. And once the job is done, you'll see how long did it take for SageMaker to run the training. It's an interesting point to point out that it took about 4 minutes and 42 seconds to start an EC2 instance, get the data, run the model, and store the result back to S3. But you only build for the amount of time that was spent on training your model, which is 84 seconds. Now that the training is done, I'm creating an experiment. I'm using SageMaker experiments to keep track of my experiments and trials. This would be really helpful later on if you're doing some research and experimenting with different set of hyperparameters or different models, to have them in one place. They are accessible from the components here in SageMaker Studio. You can look for experiments and trials, and you can see the experiment that it created is here. So you can look into the trials and get the information that is necessary or you're looking for. You can also search those experiments. You can see that I'm running that training job again now as a trial in that experiment, and I can not only see the result on SageMaker Studio, I can also get the result back here and look into all the metadata and information that I can associate with that trial, from the instance type where the data is coming to performance metrics like training AUC. But we know that usually we don't have the best set of hyperparameters to start the training with. Now that we know how to start a training job, I want to talk about hyperparameter tuning. You can use SageMaker hyperparameter tuning to use a Bayesian search strategy in order to find the best set of hyperparameters for your algorithm. When I say Bayesian search, I mean SageMaker will look at each set of tuning jobs that you're running as a regression problem, as opposed to doing a random search or a grid search. It will use the information from previous tuning jobs in order to optimize in which direction it should look in that hyperparameter space in order to get to the best result faster. We need to configure the tuning job. How many jobs do we want to run? What is the objective? Number of rounds that we are running, and we can use that also again in our experiment as a new a set of new trials. You can see that I'm in this example, I'm just picking a few hyperparameters to run the tuning job. You can see I can pass categorical ranges and continuous ranges. Configuring the training job in terms of how many number of rounds do we want to run, what is the objective function, what kind of instances are we using. Naming the hyperparameter tuning job here, and at the end we can run the tuning job. Once the hyperparameter tuning job is over, you can take the best model and directly deploy it as an endpoint. Here, we're using SageMaker batch transform. The difference between they're used for real-time inference or prediction. In batch transform, in the other hand, if you want to run your prediction on schedule on a whole data set, it makes sense to not have an endpoint continuously running, and just you can run your prediction on your data set, and once that prediction is over, you'll get the result and the instance will be terminated. So we're using batch transform to get the prediction for our test set using the best model. And you can see here I am creating a batch transform job using the best model and running that on this given configured instance. It'll take some time. We'll see the logs, and at the end of that, you can get the result back from S3. It will store it on the designated path for your output, and we can get that back to SageMaker Studio, and now we can actually compare the results from prediction with actual result. So that's what you see that is happening here. In order to have a better understanding of our model performance, you can also do, use some metrics like F1 score, precision, and recall to see how your model has performed. And as you can see, with the hyperparameter optimization, we're getting to about 0.9 for F1 score, which is a really good result. The last step that I want to talk about is, now that we have a model, now that we know the model is performing with this performance metrics, I want to understand why the model is making those kind of predictions. So that's where we can use SageMaker Clarify. SageMaker Clarify will provide you with SHAP values, which measures the importance of features for your prediction. So to create a Clarify job, we need to specify a Clarify processor. Again, we specify the instance type, instance count. There's some configuration for the data, for your endpoint as well, where the explainability report would be stored on S3. And you can see data configuration and model configuration is set here, and now we are running the explainability. To run that, you need your model to be ready. To run the explainability, you need to have a trained model. That's when you can make predictions. So it'll take some time, and we'll see Clarify will return results to you in terms of the SHAP value for each of the columns that you use when you train your model. And we can get that result and generate reports and make decision about your features. And if you need to go back and do more feature engineering, or you need to add more data, that can be a good reason for you. Everything that we do, this is an optional section. You can use SageMaker Autopilot actually from the console to have a almost no code AutoML process in order to do the classification. So I strongly recommend you go and also check SageMaker Autopilot. All you need to do is to specify the S3 bucket for your input, what is your data, where is your output, what kind of problem you're going to solve. Is it a regression problem or a classification problem? What objective metric you're looking for? And then SageMaker Autopilot will run the classification job for you, and will give you candidate notebooks that you can use and see exactly what has happened for your classification problem. All right, that would be the end of this demo. There are more information throughout this notebook, and also SageMaker documentation is a great resource for you if you have any questions or problems about each of these steps. Thank you. Now let's look at a few examples of media and entertainment companies who are using SageMaker. Here we have Thomson and Reuters. They wanted to enable machine learning at scale. The data scientists needed secure access to data while ensuring compliance with Thomson Reuters enterprise security policies. So the solution that they built is called Secure Content Workspace, or SCW. It provides access to data in compliance with internal security standards. Amazon SageMaker, enabled through SCW, provides a fully managed machine learning environment. And as a result, the data scientists are able to securely experiment at scale in compliance with their policies. They have frictionless access to cloud computing resources, which ensures intelligent and timely solutions for their customers. The next example that I want to talk about, which makes me always excited, is the NFL. The NFL enhanced their entire next-gen stats platform by using machine learning, and SageMaker is the backbone for their machine learning operations. This is another slide that I could spend many more minutes talking about it if you want, but I think the items worth highlighting out of the story are that NFL needed an optimized environment for the massive data set, enormous scaling requirements, and envelope pushing latency requirements. So the solution was NFL teamed up with AWS to transform how football is analyzed, played, coached, and experienced by fans, broadcasters, coaches, and teams. Through RFID tags attached to the players' shoulders pads and embedded in the game ball, the NFL collects large volumes of tracking data like location, speed, acceleration, and distance traveled. They chart individual movements within inches. In 2016, the NFL began working with AWS to leverage their expertise and accelerate the next-gen stats program to combine all the new data to provide players and fans with predictive stats about the game in real time. An example stat is the completion probability, which is the likelihood of a pass being completed. It's predicted based on numerous factors, including the receiver's separation from the nearest defender, the receiver's location on the field, and the separation of the passer at the time of the throw from the nearest pass rusher. There are many resources online that you can use, from our documentations to blog posts to YouTube videos to code samples. Please feel free to look them up, play around, and start building machine learning models. Thank you.